Hello, calculus rock stars. Let's continue in the AP review packet problems. Thank you to the people who brought their review packets and can actually do this on their review packet themselves. Otherwise, I printed it out for you right here, so I don't want to hear any reason why you didn't try it, please. Thank you. So this says the function is defined above, where c is a constant. That just means c is a number. If f is continuous at x equals 1, what is the value of c? Meaning, this is one of the situations where we have to force the function to be continuous. So if f is continuous at 1, that means the limit from the left of 1 of f of x has to be equal to the limit as x approaches 1 from the right. Okay? So that means limit as x approaches 1 from the left of 6 plus cx is equal to the limit as x approaches 1 from the right of 9 plus 2 natural log of x. Cool, so I'm going to plug in 1. 6 plus c times 1 should equal 9 plus 2 times natural log of 1. Now, hint, hint, natural log of 1 is 0. Please memorize that. So 2 times 0, this whole thing will just be 0. I'm left with 6 plus c equals 9. And now I have to figure out, well, what does c have to be so that 6 plus c equals 9? Well, guys, solve for c. Algebra, okay? C equals 3. That means c should be 3. Okay? That way, f is continuous at x equals 1. Okay, let's move on to number 25. F is a function with first derivative given as 3x squared minus 6. It is known that f of 1 equals 9, so that means 1 comma 9. And f of 3 equals 11, that means 3 comma 11. What value of x in the open interval 1 to 3 satisfies the conclusion of the mean value theorem? Mean value theorem, I have a few things I remember about that. I know the graph has to be continuous and differentiable. Okay. And I know the outcome of it, or the conclusion of it, is f prime of c equals to f of b minus f of a over b minus a. So they're focusing on the outcome, meaning this is true already, continuous and differentiable, and I just need to figure out what the value of c is so that the derivative is equal to the slope. Guys, all that means is take the derivative, okay, 3x squared minus 6 over x squared equals 11 minus 9 over 3 minus 1. And I got 11 and 9 from the y values and 3 minus 1 from the x values. Okay, and I'm going to solve it. 3x squared minus 6 over x squared equals 2 over 1. And from here, you need to solve for x. So I'm going to cross multiply. That becomes 3x squared minus 6 equals 2x squared. I solve for x. I get x squared equals 6, square root, x is equals to plus or minus square root of 6. So which of my options works? It's this one. Okay, so 83, I'm not going to answer that for you. You can figure out which one has a jump discontinuity. Okay? Okay, so I have the graph of h prime, meaning the derivative of h, given to me. And I need to decide, is 1 true, 2 or 3 true, okay? So if I look at this graph, I have a derivative at 1. That means there's a y value there, like 1/2, for example. If I have a derivative, then that means I'm continuous, okay? So if I have a derivative at x equals 1, I'm continuous at x equals 1. So I already know 2 is true. So I can cross off the other options here. Okay? And you can even check that 3 is not true, because if I'm continuous at x equals 1, that means my graph is continuous, let's say at x equals 1. That means, let's say this is the graph of h. I'm just approximating. Okay? Then there's no vertical asymptote here. It doesn't make sense to have a vertical asymptote there if I already said that it's continuous there. Okay? So that's why 3 is not true. Now I have to check if 1 is true. H of negative 1 is h of 3. Remember, this is h of negative 1, this is h of 3. This graph is of the derivative, not of h. This is not h. Okay, so even if the y values of this graph are equal to each other, it doesn't mean that h of negative 1 is necessarily equal to h of 3. So 1 is not necessarily true, okay? So B is the answer. Okay, for number 5, same as always, figure out if f is continuous at x equals 0. Well, I know I have to check if the limit as x approaches 0 from the left of f of x is that equal to the limit as x approaches 0 from the right of f of x. Oh, my handwriting is getting better in this app. I expect some praise when I get back. Okay, so let's see. I'm going to plug in limit as x approaches 0 from the left of 3x squared plus 2x. Is it equal to the limit as x approaches 0 from the right of e to 2x? Oh, plus 2. Okay, time to plug things in. 3 times 0 squared plus 2 times 0. E to the 2 times 0 plus 2. This whole guy becomes 1. 1 plus 2 equals to 3. Are these equal? No. No. F is not continuous at x equals 0 because the limit as x approaches 0 from the left is not equal to the limit as x approaches 0 from the right. Now I attach part C here. It says, explain why f prime of 0 does not exist. You have to remember, I don't have a derivative if I'm not continuous. And the fact that you just said it's not continuous at x equals 0 is the reason why there's no derivative there. So you're going to say f prime of 0 does not exist because f of x is not continuous at x equals 0. And that's it. You've solved the AP review problem. That's a free response. Alright, there's 3 more problems that's on your mock AP that you can now answer because of this review. It says here, I have a function that's continuous on the closed interval 1 to 3, so that just means I have a graph 1 to 3. Okay, and it tells you that the point is 1, 10 and 3, 18. So if I made a rough sketch, it's not going to be perfect. Let's say 10 is here. It's not scaled, I apologize. It's going to be okay. And 3 and 18. Okay, take a minute, make sure you know where I'm getting these points and numbers. So if the fact that I'm continuous means that I can connect these 2 dots with no problems, no holes, no jumps, no vertical asymptotes. So I'm just going to make up a graph and connect them. So like, okay. Okay, now I have a few statements and I have to figure out which one here is true. Let's do it. So f of 2 has to be in between 10 and 18. Well, let's say 2 is right here. Let's say 2 is right here, and this is a dot here, and that's, let's say, 21. I'm making it up, okay? Is 21 necessarily in between 10 and 18? No, it's not. And also, this is not true because you, as we saw in this graph, you can have a y value that's above 18 or below 18. or maybe below 10, or maybe even between 10 and 18. Meaning this is not necessarily true based on our picture, okay? So that's not the answer. For B, is it increasing always? Well, look, first I'm decreasing, then I'm increasing, then I'm decreasing. So that's not necessarily true, okay? Okay, C says f of x equals 17, so 17 on the y value. 17 is right here. So it's saying at least one solution in between 1 and 3 is 17. So it's saying at least one time the y value is going to be 17. Well, that's true, because there's no way I can make this graph without crossing 17. Okay? If I want to get from this dot A to this dot, I'm sorry, f of A and f of B, I need to cross 17 somehow. No matter what I do, I can make a bunch of graphs, and there's no graph that I can get that doesn't cross 17. Okay? So this has to be true. C has to be true. So that is the answer. Okay, now the next one is f is a continuous function where f of 2 equals 6, so that's 2 comma 6. I have a graph, okay, where I have a 2, I have a 6, and there's a point here, and f is continuous, so let's just pretend that I'm making a graph here. Okay, just made a graph. Okay. Okay, let's go over A, limit Sx approaches 1 of f of 2x. So 2x, and our x is 2, so 2 times 2 will be 4, is 3. Is that necessarily true? Let's go to 4. Let's say 4 is right here. Does it have to be 3? No. In our example graph, it's 0, so A is not true. Now the next one, B, it says the limit as x approaches 1 of f of 4 should be 12. Well, let's go to 12. Oh, sorry, 4. Does this y value necessarily have to be 12? No, doesn't. Okay, it doesn't. Next one, limit as x approaches 2 of f of x minus f of 2 over x minus 2 has to be 6. Well, even if I try to solve that, limit x approaches 2 of f of x minus f of 2 over x minus 2. I can plug in for 2 here. It'll be 6 minus 6 over 2 minus 2. Well, that's 0 over 0, okay? So that doesn't even make sense for us. This is not an option. Next one, f of x squared. So that means f of 4 equals 36. Is that true? Let's go to 4. No, y value doesn't have to be 36. So obviously we're left with one choice, E, but we can even check that. It says limit as x approaches 2 of f of x squared equals 36. Well, let's check. F of 2 squared. F of 2 we know is 6 squared, and 6 squared is 36. Okay? So that one's true. Finally. Number 6. This is the same as all the other problems we've done as free response that shows if f is continuous. I have to see if the limit as x approaches 1 from the left of f of x, is it equal to the limit as x approaches 1 from the right of f of x? Okay, so limit as x approaches 1 from the left, 10 minus 2x minus x squared. And then I'm going to do limit as x approaches 1 from the right of 3 plus 4e to the x minus 1. Plug in 10 minus 2 times 1 minus 1 squared. 3 plus 4e to the 1 minus 1. 10 minus 2 minus 1 is 7. So this guy becomes a 1. 3 plus 4 equals 7. Are they equal? Yes, they're equal. So you're going to say, yes, f is continuous at x equals 1 because the limit as x approaches 1 from the left is equal to the limit as x approaches 1 from the right. Okay, scholars, you've done so much good work. Thank you so much for being patient with everything. please rewind to any problem and play it again so that you can make sure that you know what's going on. You see where the numbers are coming from, and you see the reasoning behind them. Okay. I will see you soon, and we're going to go over some more problems on limits and continuity. Thanks for tuning in.